All right, this week in math, we're going to be talking about relations and functions. So a relation is any set of ordered pairs, and for each first member, there may be multiple second members. Why is that important? Well, because a function is a type of relation where you have a set of inputs and a set of outputs with the property that for each input, there's exactly one output. So some relations are functions, and all functions are relations. So the question we usually are asked is it a function? How can you decide if it's a function? Well, you want to check and make sure that there is only one output for every input. In other words, that there is only one y that corresponds to a particular x. Let's look at some examples. All right, there's different ways that we can represent relations and ways they can be presented, and we're going to have to decide if they are functions or not. Once again, remember, it is a function. It is that special situation if there is just one output for every input, one y for every x, because x is what you put into the expression, y is what comes out. So here is one example we might see. We might see a table. Here are my x's, here are my y's. We're looking to make sure that for every x, there is exactly one y. Well, when your x's do not repeat, like in this situation, then yes, that is going to be a function. Is this one over here a function? Well, let's look. I do have two of the same x's, but look, they're paired with the same y. So is this a function? Yes, this one is also a function. Let's look at a couple more tables. In this one, I do have a repeating x, and look, this one is paired with a 3, and this one is paired with a -2. So no, this one is not a function because I can see there's two different y's paired with the same x. There's two different outputs for that one input. Let's look at how else we might see relations and functions represented. Here's the table. This one's just presented vertically. So here are my x's, here are my y's. What do you think? Is this a function? Here are my x's, here are my y's. Is this a function? Go ahead and put your answer in the blank. All right, let's look at another situation. These are ordered pairs, so a set of ordered pairs. That's what the little brackets around the outside show you, that it's a set of ordered pairs. Remember, your first number is x, your input. The second number in your ordered pair is y, your output. So we're looking to see, is there a situation where there are more than one y's paired with the same x? Well, if I look here, let me grab a pen, I can see these two both have the same x. And are they paired with different y's? Yes, they are. So is this a function? No, that eliminates this as a function because we have more than one output for the same input. Let's look at this one. I see right here that this x repeats and they are paired with different y's. So this is also not a function. Same thing here. Let's look at this one. I have different x's. There are no repeating, so this must be a function. Does it matter that these y's repeated? No, because they have different inputs. It doesn't matter if they have the same output. It's just for every input, it only matches up with one output. So it is okay to have repeating y's. It is not okay to have repeating x's. Let's look at yet another example. These are called mappings. So your input x is shown in the first circle, and it is mapped or connected to its corresponding output or outputs y in the second circle. You may also hear those referred to as domain and range. So I'm looking to see, is there any one x that's being mapped or paired with two different y's? If we have the same x being paired with two different y's, so more than one output for that input, then no, that is not a function. But if every single x is paired with a different y, or excuse me, is paired to just one y, it doesn't matter if they're paired to the same y, as long as each x is only paired with one y, then yes, this is a function. Once again, each x can only be paired with one y. It does not matter if we have two x's paired with the same y, as long as each x is only paired with one y. All right, we may also need to look at a graph. So since we're going to be talking about graphs, let's review graphs real quick. If I graph 2 points with the same x coordinates, they will always form a vertical line. Well, let's graph some and see. So the first number always tells me how far to go over. The second number always tells me how far to go up or down. So I'm going to 3, 2, that's this point right here. My next one is 3, -3, and then 3, 0. They all have the same x, and notice they do form a vertical line. Let's look over here at this one, see if it works if we have the same negative number in first. So -4, I go back 4, and +1, always over and then up. -4, -2, -4, 0. They all have the same x value, and they're paired with a different y, and they make a vertical line. So if a function only has one output for every input, or only one x for every y, it will never have 2 points that are in the same vertical line. So it will pass what is called the vertical line test. And the vertical line test just says that if I draw a straight line, let me go ahead and grab one here and draw it. Let's make it a color that I don't see on here, maybe this orange. And I'm just going to draw a straight line, a vertical line. And if I take this straight line and I move it across here, and it's a function, then I will never cross 2 points that are in the same vertical line. Well, right here, I just crossed these 2 points. They're in the same vertical line. So I can say that this is not a function. It did not pass the vertical line test. Let's check this next one. So I've got my vertical line. I'm checking to see, is there ever a point where I crossed 2 points? There was not. So guess what? This is a function. It does pass the vertical line test. Let's look at this one. This is a little bit different. Kind of grab my line again. Right here, I'm not passing the vertical line test, in fact, this whole way, because I'm crossing that line more than once. So this is not a function. It does not pass the vertical line test. And if I look at this last one, sorry, you got to keep remembering to grab my line. This one, even though it's also a line instead of set of points, it does pass the vertical line test. And so this one would be a yes. This is a function, because we never, when I take my vertical line, it never crosses through 2 points at once. Once again, just a reminder, that's called the vertical line test, and a vertical line is a straight up and down line. If you think about the vertical jump at the NFL Combine, they're seeing how high they can jump straight up. So that is a vertical line, and it is our vertical line test that determines whether a relation in graph form is a function or not. You're going to practice doing this with a Google form assignment next.